In this PowerPoint, we are looking at other elasticities. So the previous one we were looking at price elasticity of demand, but now we'll be looking at cross-price elasticity of demand when we're comparing the effect of a change in price of one good on the quantity demanded of a different good. We'll look at income elasticity of demand and how quantity demanded changes when your income either increases or decreases, and price elasticity of supply. We've looked previously at price elasticity of demand, but this time we're going to look at the cross-price elasticity of demand when we're looking at two goods and seeing the effect of a change in price of one on the quantity demanded of the other. So this measures how the quantity demanded of one good changes as the price of another good changes. This is particularly useful when tracking the changes in the prices of complements or substitutes. So just a reminder, a complement is something that you use with something else. So an example could be DVDs and DVD players. Substitutes are when you are somewhat indifferent to either consuming one product or another, such as ice cream or frozen yogurt. So the formula is the cross-price elasticity of demand equals the percentage change in quantity demanded of good A over the percentage change in price of good B. And the short form, just like we saw with price elasticity of demand, percentage delta quantity demanded good A, so in other words, percentage change in quantity of good A over percentage change in the price of good B. The sign, unlike price elasticity of demand, when it was negative and we ignored the fact that it was negative, this time the sign of the cross elasticity of demand is crucially important, so whether it's positive or negative. Also, the magnitude or the size of the cross elasticity of demand, how large or small its numerical value, is also very important. So there's quite a difference between 0.003 versus 3. So what would you expect the sign to be for complements? So if you're thinking of a complement, give yourself an example. So the picture, it's gasoline and cars. So if the price of a complement rises, so such as if the price of cars rises, would the quantity demanded for the other good increase or decrease? So let's have, as I said, the quantity of the price of cars going up. So if we're buying fewer cars, we would expect to then buy less gas. So the quantity demanded of gas would decrease. So in this case, it would be negative. I encourage you not to memorize this. If you are asked this in a test or exam situation, quickly give yourself an example of two complements and figure out what's going to happen. The larger the numerical value, the greater the complementarity between the two goods. So the larger the number, the stronger that relationship of the goods being complements is. What would you expect the sign to be for substitutes? So let's have the price of, let's say, oranges goes up. People then would switch from oranges to buying more apples, and we'd expect the quantity demanded of apples to go up. Likewise, let's say the price of oranges were to go down, then we would have people switching from apples to oranges, and the quantity demanded of apples would go down. So in this case, it's going to be positive. Again, try not to memorize this, but quickly give yourself an example. So the larger the value, the greater the substitutability between the two goods. What would a zero or near zero cross-price elasticity of demand signify? So we have the price of one good going up, not really affecting at all the change in quantity demanded of another good, or the price of the one good going down and really not affecting the quantity of the other good. So these would be things that have nothing in common. So we could look at computers and skipping rope. And I'm sure you can think of many, many examples of things that really would not have any particular relationship with each other. So what can we conclude about the relationships of good A and B in the following situations? And I encourage you to give examples of each. Okay, so the quantity of good A increases by 10% in response to a price decrease of good B of 15%. Okay, so we have a price decrease of one good and the quantity of something else increasing. Complements. But let's think of the DVDs and DVD players, and let's make sure that we didn't make a mistake. We've got the quantity of good A increases by 10%, so let's say the quantity of DVD players goes up by 10%, and that was in response to DVDs being cheaper. Well, that makes sense. The quantity of good B decreases by 10% in response to a price decrease in good A of 15%. So let's say substitutes. But let's make sure, so let's say tea and coffee. And let's go back to the question. The quantity of good B decreases, so less coffee is consumed in response to a price decrease in good A of 15%. So if the price of tea goes down, we would expect people to consume less coffee because they would switch their purchase to more tea. So the quantity of good B remains unchanged in response to a price decrease in good A of 15%. So nothing in common. So we could say shoes and tennis rackets. If the cross-elasticity of demand between Coca-Cola and Pepsi is 0.7, how will the quantity of Coca-Cola demanded change if the price of Pepsi increases by 5%? Okay, so that's a lot to take in. Let's look at the formula. So the cross-elasticity of demand is going to equal the percentage change in quantity demanded, product A, over the percentage change in price of product B. Okay, so what's happening here? We know that this is going to be 0.7. I'll just put that over 1. And that's going to equal, so how will the quantity of Coca-Cola demanded change? So this is going to be our X. If the price of Pepsi increases by 5%. Okay, and so let X equal quantity of Coca-Cola that has changed. Maybe we could have made that into tighter English, but you get the idea. So let's cross multiply. We have X equals 0.7 times 5%. So X equals 3.5%. Okay, 0.7 times 5. Let's just make sure no mistakes have been made. 3.5. So, and this, let me see, just to check. The price of Pepsi increased by 5%, so that's positive. We don't have any negatives. Our answer is positive. So, it makes sense that if the price of Pepsi increased by 5%, more people would buy Coca-Cola. And how much more Coca-Cola would be demanded? It would be 3.5% more cola is demanded. Now this can be very useful if you are the manager or supervisor of a large grocery chain or grocery store, and you know that that Pepsi has increased their price and you don't want to run out of Coca-Cola. You want to make sure that it's still stocked on the shelves, and you'll know to stock it more by 3.5%. So now we're going to look at something called income elasticity of demand, and it's going to measure how quantity demanded changes as consumer income changes. So with most goods, we call them normal goods, if your income goes up, your quantity demanded of a good will also increase. But if your income goes up by a certain amount, are you going to have substantially or relatively more quantity demanded, or just a little bit more quantity demanded? So this would be for normal goods. We know for inferior goods, if your income goes up, your quantity demanded will actually go down. And in this case, looking at the formula, your answer is going to be negative. So the income elasticity of demand is percentage change in quantity demanded over percentage change in income. And the formula in the short form is like this. And note, for income, we use the letter Y. I has been reserved for imports. So you're going to see Y being used for income in a number of situations with in economics. We use it also for national income. We use Y. You might have noticed this in the circular flow of income. So normal goods. So higher incomes. So we know that if income goes up, we know that quantity demanded is going to go up. Do they move in the same direction? Yes. So it's going to be positive sign for normal goods. And the same thing, if income goes down for a normal good, your quantity demanded would also go down. Inferior goods. Some examples of inferior goods could be second-hand clothes, it could be gruel instead of rice, or something more interesting, or pasta, or meat, and so on. So what would the sign be for inferior goods? So you have, let's say, income goes up, quantity demanded goes down, because you are earning more. You can now get rid of these things that you don't want to consume. On the other hand, if your income goes down, and you don't have enough money for the finer things that you would prefer, the quantity demanded in this case will go up. So we're going to expect the sign to be negative. And we are going to keep the sign for these goods. Unlike the only one where we discard the sign is price elasticity of demand. And here's the formula again. So the example I like to use is Spam in terms of an inferior good. If your income goes up, perhaps you want to move to a better cut of meat, or a better type of meat. So how would the magnitude of income elasticity of demand compare for necessities versus luxury goods? So if your income goes up, are you going to buy substantially more food or water or housing? Probably not. So this is probably going to be small. If your income goes up and you've been really waiting to take that wonderful vacation, this is probably going to be considerably larger. The same thing happens if your income goes down. Are you going to eat considerably less food and water and so on? Chances are no, so it would be again small. But if your income goes down, are you going to give up the luxury goods and focus more on the necessities? Most likely the answer would be yes. So again, the magnitude would be larger. So here's a tester for us to use the formula. We have a scenario where your income increases from $1,100 a month to $1,200 a month. And as a result, you increase your purchases of pizza from 8 to 12 per month, and you decrease cheese sandwich purchases from 15 to 10 per month. So in this case, we're not given the percentage change formula, so we have to use the quantity 1, quantity 2, income 1, and income 2 version. So let's first of all look at the formula that we've been presented. So income elasticity of demand equals percentage change in quantity demanded over percentage change in income. Remember, income is represented by a Y. So we'll have the case of, remember the animal that made the sound new? We have new minus old divided by old. So we'd have Q2 minus Q1 over Q1. And we're dividing by Y2 minus Y1 over Y1. Let's just do a check. New minus old divided by old. New minus old divided by old. So let's bullet out what Q1, Q2 are, and then Y1 and Y2. So in the case of, let's first of all look at pizza. So for pizza, we have purchases of pizza going from 8, so that's the original, to 12. Let's look at the income, Y1, Y2. Your income is going from 1,000 to 1,200. Okay, now that we've written the formula out, we've identified Q1, Q2, Y1, Y2. Unless we make some algebra mistake, we shouldn't slip up. So let's look at the YED. We've got Q2, which is 12, minus Q1, which is 8. I'm going to divide by 8. And then rather than putting a fraction on top of the fraction, I'm going to say divided by. Our Y2 is 1,200. Our Y1 is 1,000. And it's going to be over 1,000. So then we have 12 minus 8 is 4 over 8 divided by 200 over 1,000. And our signs are all correct. There's no negatives. So simplifying, we'll have 1/2. So this is 1/2. Let's get rid of the zeros here. And let's multiply by the reciprocal. So 2/10 becomes 1/5. So we're going to multiply by 5 over 1, which will be 5/2, which is 2.5. Okay, now let's look at the case of cheese sandwiches. Okay, so in the case of cheese sandwiches, we know that our Q1 and our Q2, so we've gone from 15 cheese sandwiches to 10. All right, so let's look at the formula, the YED. So we know that Q2 is 10. Q1 is 15, divide by Q1, which is 15. Now we've done all of the work already with the income, so we know we're dividing by 1/5. And that we picked up over here. So it's going to be -5 over 15. We're going to multiply by the reciprocal, 5 over 1. Simplify, and we have -5/3, which equals -1.67. So we know in the case that pizza, because it's positive, is a normal good. So what happened? Let's just double check. Our income went up and we bought more pizza. But cheese sandwiches are an inferior good. Again, let's just, inferior. And let's just confirm that. Our salary went up, but then we purchased fewer cheese sandwiches. The income elasticity of demand for food in more developed countries is 0.15 to 0.2, so fairly inelastic. The income elasticity of demand for food in less developed countries is 0.18. So what would be the difference in these estimates? Well, chances are in a developed country, hopefully most people are having enough food on their plate, on the table. So if their income goes up, they're not going to buy a whole lot more food. But in the case of less developed countries, where food, they might not have sufficient food, they might not have sufficient housing and clothing and so on, if their income goes up, they'll be probably more disposed to buying more food because it's been lacking in the past. Income elasticity of demand and sectoral change in an economy. Now, it's important to know what primary, secondary, and tertiary sectors are. We may not discuss this at length again in this course, but you'll be expected to know what they are. So please be aware that primary sector is dominated by agriculture, but also includes fishing, forestry, and all extractive activities such as mining. Then we move up into a more developed economy, and we refer to the secondary sector, which is manufacturing. And in an even more developed economy, we tend to see more of a tertiary sector, which includes commerce, finance, transportation, and all other services. So tertiary, think of services, education, healthcare, etc., and is referred to as the services sector. So what happens to these sectors as a country grows and becomes more economically developed? Well, I've already sort of mentioned that. As an economy becomes more developed, they move more and more away from the primary and towards the tertiary sector. Using the concept of income elasticity of demand, explain why agriculture is often referred to as a declining industry. Why do agricultural products prices tend to fall relative to prices of manufactured products over the long term? Well, as parts of the world increase their incomes and become wealthier, what kind of products will they prefer to consume more of? Well, chances are they probably have enough of the agricultural products and the necessities of food. So they will move more to the manufactured products and more towards the service products, goods and services. So as the world, if the world is increasing in income, it'll be the primary sector that's left behind in terms of an increased demand, and more the secondary and tertiary sectors that will take off and be in greater demand. So now we'll look at price elasticity of supply and its determinants. If you're curious as to what these drums are, these are giant drums of Quebec maple syrup. So the law of supply. Producers will make more goods and services available for sale at higher prices. So as the price goes up, we know that quantity supplied is going to go up, and that's why we have an upward sloping supply curve. Now, price elasticity of supply, or PES, is going to help to answer the question, well, how much more? So if the price increases, are we going to make substantially more or just a little bit more? Price elasticity of supply. In terms of the formula, and even the concept, it's very similar to the price elasticity of demand. So the definition of PES. Price elasticity of supply is a measure of how much quantity supplied of a good responds to a change in the price of the good. Its formula is again very similar to PED, percentage change in quantity supplied over percentage change in price. And you'll see this formula being used over and over again. Again, percentage change in quantity supplied over percentage change in price. Elastic versus inelastic supply. An elastic supply means that there's a large change in quantity supplied when the price goes up. And an inelastic supply means that there's a small change. And of course, with all of these types of elasticity, it happens in the opposite direction as well. So the elastic supply, just as an example, is that there'd be a large change in quantity supplied, meaning like a decrease in it, when the price goes down. Determinants of elasticity of supply. So what makes the change either be great or negligible? Well, the flexibility of sellers to change their production. So examples, beachfront land developers, elastic or inelastic? Well, if you've been to Miami and you see that the beachfront is very much being used up, if the price of condos goes up, it's very difficult to increase the supply by much because the land has already been taken up. So it would tend to be inelastic. Paperback books, probably fairly easy to be able to crank up production if the price should go up. So most likely it's elastic. The mobility of factors of production. So let's say you are producing both basketballs and volleyballs. And if the factors of production could be easily switched from manufacturing one to the other, then it would tend to be quite elastic. Time period. Supply is more elastic in the long run than in the short run. This is the same thing as for PED. In the short run, firms find it difficult to change the amount they supply. But in the long run, they can build new plants, close old factories, they can train workers, all sorts of different things that they can do in the long run to respond to an increase in price. The level of spare capacity available. If there are machines not being used, extra plant space, etc., then it will be easier to increase production if price increases. So I suspect the picture on the right, it looks like the shop floor is pretty well used to capacity. We've got someone at every sewing machine. If the price went up, it might be difficult to be able to respond with producing more. But on the left, highly mechanized, assuming that all the machines are not at full capacity, then in this case they probably could respond quite easily to an increase in price, and hence it would be more elastic. Availability of inputs. If there's a ready supply of raw materials, then it's going to be easier to increase production if the price increases. Now this is an example of cobalt on the left, used in smartphone manufacturing, and there have been concerns raised that there is going to be, or there have been, material shortages. So in this case, if we can't get hold of enough cobalt, then it would be very difficult to increase the production of smartphones. So it would tend to be inelastic. Storage capacity. So again, on the left is that wonderful Quebec maple syrup. If a firm is able to store high products of stock, this will make a difference in terms of their responsiveness to an increase in price. So in the case of tomatoes, I don't know about your household, but we find it difficult to keep them around for more than 3 or 4 days without them spoiling. So it's very difficult to stockpile tomatoes, but it would be easy to stockpile maple syrup, and so you would be able to respond better with the maple syrup to an increase in price. Now, the supply curves, just like in PED, is identical in terms of the shape. So perfectly inelastic. Remember, this can look like an eye if we put a dot over it. So it's completely vertical, and we say that the price elasticity of supply is 0. Now, if you forget that, I know myself, I can't remember that a perfectly inelastic curve is 0. I would just quickly look at the formula. So PES equals percentage change in quantity supplied, not demanded, because we're looking at PES over percentage change in price. So here we could have price changing, and so we would have some value if we were to calculate that. But in terms of quantity supplied, it's remaining there, so it would be 0. So 0 over some value, of course, is 0. Perfectly elastic. Again, if we were to draw another line up here, it looks like an E, so we know this one is the perfectly elastic. PS approaches infinity in this case. So again, if we look at the formula, percentage change in quantity supplied over percentage change in price. If we moved along here, we know that we could have some value for the numerator, but we see that the price remains the same, so it's over 0. So if you take any value with your calculator, if you take any value as the numerator and divide it by something very close to 0, like 0.0000001, you'll see that the number gets very, very large. And as discussed with PED, when you divide by 0, some mathematicians will say undefined, and others will say infinite. So in the case of the economists, they are siding with the value of infinite. Any straight line supply curve that goes through the origin will have a price elasticity of supply of 1. If you want a proof of this, go on to the Blackboard course, and I've posted a proof that I've done just to show or convince you that that is indeed the case. It sounds rather strange, but look at the proof if you do want an explanation as to mathematically why this works out. So when the linear supply curves pass through the origin, it's important not to confuse the steepness of the curve with the elasticity of the curve, because they all have a PES of 1. All right. Let's look at calculating the price elasticity of supply for each of these 3 time periods. Now, we have been told that price elasticity of supply will become more elastic the longer the time frame. So let's see if these numbers play out to be the case. So we want PES, it's going to equal percentage change in quantity supplied over percentage change in price. And again, we don't have percentages here, so we have to think of our animal that makes the sound new minus old over old. So we know that's going to be Q2 minus Q1 over Q1. And we're going to divide by P2 minus P1 over P1. Now, we've got the price changing from $10 to $15 for the cases of A, B, and C. So let's off to the side. Let's look at P1 and P2. So P1, it increases from $10 to $15. So we'll be able to use this value for all of our calculations. So let's look at number A. It does not respond at all in the first week. So in the case of the PES, equals percentage change quantity supplied over percentage change in price, and if it doesn't change, then the numerator must be 0. So we won't even bother estimating the percentage change in price, because we know the answer is going to be 0. Let's look at 2. We've got a Q1 and a Q2. It increases from 10,000 units to 12,000 units over 5 months. So let's look at the formula. Let's take it from up here. So Q2 is 12,000 minus 10,000 over 10,000. And we're going to divide by P2 is 15 minus 10 over 10. So this would be 2,000 over 10,000, and divided by 15 minus 10 is 5, 10. Okay, and let's just save room for C. So simplifying, 2, 3. So we've got 1/5 being multiplied by 2 over 1. So 2/5 or 2.5. That's our answer. Let's look at C now. We have it increasing from 10,000. So Q1 is 10,000. Q2 is going to equal 18,000. So let's look at the PES. It's going to equal So it's Q2 minus Q1, so 18,000 minus 10,000 divided by 10,000. And we're dividing by, let's take this value here, which we can simplify to 1 over 2. And so we would have 18 minus 10 is 18 over the 10,000 times 2 over 1. 2, 3, 1, 2, 3. And we would be left with 36 over 10, which 36 over 10, which equals 3.6. And lo and behold, as the time frame increased, we went from a PES of 0 to 2.5 to 3.6, and so it certainly did become more elastic over time. The short-run PES for green peas is 0.31, whereas the long-run PES is 4.4, so that's quite a difference. So why the difference? Well, in one growing season, if the price of peas went up, is it easy to grow more peas? So it's difficult to grow more peas. In more than one season, you can plant more peas. You could take land from other uses and dedicate to growing peas. You could buy more land, you could hire more workers, all sorts of things. So you can see in the long run, there, especially for agriculture, there's a huge difference between one growing season and more than one growing season. In general, agricultural products, as well as other primary products, tend to have a lower price elasticity of supply than industrialized or manufactured products, particularly over short periods of time. Well, the reason being manufactured products or industrialized products, it can be relatively easy to add on, for instance, another shift of labor. So instead of working for 8 hours, you could work for 16 or even have 3 shifts and keep it going continuously over 24 hours. You could quickly get more machines and be working the machines and so on. So there tends to be a greater ability to be able to increase production if there's an increase in price, if we're dealing with industrialized or manufactured goods. And why does demand for agricultural products fluctuate? Well, within any particular country, the demand for food we know needs to be is relatively stable, so the price elasticity of demand is not great. But if you're looking at exporting, so if a country exports a relatively large portion of its agricultural output, then a part of its total demand for agricultural products will be made up of foreign demand. And foreign demand for agricultural products can be unstable for several reasons. One, if you've got crop failures in other countries, this can raise foreign demand, while a good harvest will lower it. Increased production of farmers in other countries through government policies such as price supports or quotas and tariffs will lower foreign demand, whereas reduced protections will increase it. And lastly, changes in consumer tastes can also affect demand. How does a change for agricultural products impact price and hence revenue for agricultural products? So assuming that supply is inelastic, and we also know that PED tends to be inelastic for agricultural goods as well. So let's have an increase in demand. So before the increase, let's call this PE. We'll call this QE. We'll call this D1. So let's increase demand, showing it with the horizontal arrows, to D2. Now we can see that the price is quite significant, and the quantity not so much. So we can see that price can fluctuate significantly. Now, while I haven't shown you this on this graph, if you were to decrease demand, you would also see, well, we could actually do this here. Let's say if demand went to here, we'll call this D3, and compare it to the original price. So this would be P3 and Q3. Again, we'll have quite a decrease in price with not that much of a difference in quantity. So again, price can fluctuate whether it's upwards or downwards significantly when we're dealing with these inelastic demand and supply curves. So that's why you can see agricultural products changing in price quite significantly. Commodities. A commodity, again, we may not discuss this much over the next 2 years in terms of a definition, so please understand what it is now. So commodities or primary commodities is another word for raw materials such as cotton or coffee. And the PED for commodities tends to be inelastic as they are necessities to the consumer and they have few or no substitutes. We will look in class at 3 interesting case studies, and we will also post these case studies on Blackboard, but this will be a chance for you to look at some situations, real-life scenarios, in terms of using your knowledge of the different elasticities. Thank you.